Hi, welcome. And so this video is gonna be really chill. Chill. The reason why, because well, there's nothing much to talk in this point here. And again, it has a little bit repetition. My apology. And so now, remember on the last video when we talk about considering this? Oh no, not like this one. So I'm evaluating from -1 to 1, right? And so if I'm saying, well, if I want to integrating from this function, so this function is y is equal to x, right? And so if I say, well, I want to integrate this from -1 to 1 of function x, then for sure 100% I get equals to 0. Now, why is that? It's all because, well, this side of the area, which is the negative side of the area, is equal to the positive side of the area. And so if I remember last time, this say, well, because this one is negative side, this one is -1/2, right? And so this one is positive side, is positive negative 1/2. So these two things subtracting out equal to 0, right? It makes sense. And so the way we're going to avoid that, well, we're saying, well, I know if I want to find the area of this two side here, I only need the area on one side, and then I times 2, right? And so what we did is that, well, is equal to, so I'm integrating from 0 to 1 of the function x here. Now if I remember, so it's not remember correctly, then I not remember correctly, but again, is equal to 1, right? So that means uh, both side here has the area equal to 1. Now, what other interpretation is that we'll notice, so you will notice that it's 2 times 1/2. So it equivalent is equal to a half plus a half. Now previously we talk about if we do this guy over here, right, is equal to -1/2 plus a half. All right, so, well, so what we basically doing is we switching that negative side over this guy, turn it to positive side, and we got the total area, right? And so that's how we figure it out, right? So to remember the sine function, that's work exactly the same way. So I'm going to draw the x-axis better than the last time, right? So again, so it works better than it's work exactly like the last time. So y equal to sine x, all right? And again, so this part area here, you may realize that is equal to this part of area here. My bad in drawing, but they should be equal because again, they are the same interval. So 100%, if I evaluate this one from uh, 0 to 2 pi of the function sine x, now we went through this and we're saying it's equal to 0 for sure, right? Again, the trick we do it is, again, we find the middle point, we determine the middle point here. We're saying, well, if I want to find the area of those two parts, I only need the area of this part over here, one of them, and not one of them, but the only positive part, I times 2, right? So this one here, so if I remember correctly, we got 2 times 2 is equal to 4. Now that's how we get it. So in this case, this one here is actually -2 plus 2. This one is 2 times 2. So we change the negative side here to positive. That's basically what we're doing. Now, if I have two sides, so the two sides, the positive, the negative side of the area are equal, then it follows this case. This is formula. Now it's easy to understand and easy to deal with it, right? But in case, imagine I have a case like this, okay? Now I have a case, there's a same function, y is equal to x, but this is a little bit more challenging. Again, just drawing the line better. Now it's a little bit challenging, whereas, um, well, what if I'm asking you to measure me this one from A to B? Now you clearly we see the area in A, right, is 100% less than the area in B, right? And of course, let's call this one, and of course this area, because it's in negative side, so let's call it negative A, okay? And this one bigger area here, let's call it the area B, capital B. Now, if I add them together, so negative A plus positive B, 100% less than the true area. Now, even though the area is positive. Now, this one is very important because again, when later on we're going to talk about, and kind of you see the title and you can guess what the later on talk about, right? what the later on example will be about. But again, the important thing is even though the area is positive, but it's less than the true area, right? The true area, how we're gonna measure is we turn this is equal to A, so we turn this negative A back to A plus B, right? But again, if I do the integrating from A and B, sorry, from A to B of this function x, then I get negative A plus B. All right, so these two are completely different. Yeah, and the next one, the next equation, the next problem, of course, you already guessed it. So I'm gonna write the same function here, right? And so this one is A, right? This one is B. Now you can clearly concluding that the area on A side is much bigger than the area on the B side. And now without doing the integral, so let's just say f of x this time I'm lazy. So f of x is much what the heck is that lazy? Oh my god, what am I saying? Now so if I integrating from A to B of the function f of x, I should write x instead of x of f of x. My god. Now you can see, well, if I doing this integrating, that means this part here is negative A, so let's call it negative C. Let's just change its name, and let's call this one is D. Now it's equal to negative C plus D, and of course it's less than true area. Right, what's the true area again? The true area is I want to take the area C plus D, right? And the craziest thing for this guy over here is an area is negative. Now, can an area be a negative? An area can never, ever be negative. And so this one is completely nonsense, right? Not making any sense at all. And so how can we deal with this? So if you take your time out, you will say, oh, okay, it's very easy. I just need to convert the negative C over here to positive C. But how? How can you do that in definite integral? If you talk about you can use this triangle, you can calculate the area under the curve by the triangle, that's cool. But imagine, because the definite integral can deal with some curvy, some strange graph like this, right? You like this, right? And so this one is interval from A, and this one is B, let's say, right? You cannot calculate by using any of the Euclidean geometry area that you know, like triangle, square, rectangle. None of those area you know can help you to solving this, right? If you ever seen this case, how can you do this? Again, this part here is negative, this part here is positive. How can you do this? The same question go with this. If I have to do the integral from this of this interval from A to B, and then one of the area is negative, how can I deal with this? So we have the two scenario in here. I'll let you take us some time and think about it. And for now, alright. But yeah, so take us some time to think about it. If you came up with the answer, go to the next video and save your correct. And so I'll see you in the next video. For now, bye bye.